Module 8, Investigation 3, Trigonometric Identities. Answer parts A through D using the following right triangle. Use the Pythagorean theorem to determine the relationship between x, y, and r. Alright, how about this? X squared plus y squared equals r squared. Alright, determine a formula relating cosine of theta and x. Let's see, I know that cosine of theta is the adjacent side, which is x, over the hypotenuse. I could multiply both sides by r to get r cosine theta equals x. Determine a formula relating sine of theta and y. Well, I know that sine of theta equals the opposite side, which is y, divided by the hypotenuse r. Multiplying both sides by r gives us r sine theta equals y. Rewrite the relationship determined in part A using only cosine of theta, sine theta, and r. So we have x squared plus y squared equals r squared. So what we're going to use is substitution. In place of this x, I can put r cosine theta, or in place of the, because I know x equals r cosine theta. I also know y equals r sine theta, so I can replace or substitute the y with r sine theta. Squared equals r squared. Let's do a little bit of simplifying here. This just means r squared times cosine squared plus r squared times sine squared. These are by the rules of exponents, equals r squared. Notice that, well, I wonder if that's all the... I think that there's something we could do here. Notice r squared is common to each term. Like I could factor out r squared on this side. And I could divide both sides by r squared, and that gives me cosine squared theta plus sine squared theta equals 1. Now, this is a really important identity. It's called the Pythagorean identity. And I've heard that it's on the departmental final exam, and you need to know that. We'll talk more about it. Simplify the following expressions to create a trigonometric identity. In other words, rewrite the following expressions in their most simplified form. Well, first thing, we need to remember what cosecant and secant are. Let's see. So, remember sine theta is opposite over hypotenuse. And what we call cosecant theta is the hypotenuse over the opposite. It's really just 1 over the sine of theta. Notice that that also means that sine of theta is 1 over cosecant theta. Remember, cosine theta is adjacent over hypotenuse, which means, well, this is just another definition. The secant theta is hypotenuse over adjacent, which means that's 1 over cosine theta. It's just flipped. Also, tangent of theta is opposite over adjacent. So cotangent of theta, that's the adjacent over the opposite. These are called the reciprocal identities. This is just 1 over the tangent of theta. And likewise, tangent of theta is 1 over cotangent of theta. So anyways, what can we do? Notice that sine over cosecant, that's just sine times 1 over, actually, what is that? Let's think about it like this. This is sine of x over 1 over sine of x plus cosine of x over 1 over cosine of x. And so let's just flip and multiply. This becomes sine squared x plus cosine squared x, which, remember from what we've just done up here, that equals 1. So this whole identity right here equals 1. Okay, let's see what we can do with this one. These are kind of like puzzles. You just got to try some things and see what works. Tangent of x times cotangent of x. Well, cotangent of x is just 1 over tangent of x. So this will just become 1 over cosecant of x, which is just sine of x. So this whole expression here simply equals sine of x. Part C, sine of x times tangent of x plus cosine of x. So sine of x, let's see, times tangent of x plus cosine of x. Know that tangent is sine over cosine. This means that we have sine squared x over cosine of x plus cosine of x. Now maybe we should get common denominators. This is over 1, so I can multiply this by cosine of x over cosine of x. That gives us sine squared x plus cosine squared of x over cosine of x, which again, this, remember, is 1 over cosine of x, which is secant of x. So this whole big mess here we can simply write as secant of x, and their equivalent. Number 3, algebraically prove the following identities. In other words, choose the expression on one side of the equal sign and simplify this expression to equal the expression on the other side of the equal sign. So I want to prove this one in a slightly different way. To prove this one, we can just start what we know. And we know from problem 1 that sine squared x plus cosine squared x equals 1. Now, that means that it's also true that if we divide each of these sides by sine squared x, we're going to have equality. Well, let's use cosine squared x, actually. This is going to be true also. Now this is equivalent to just dividing each term by cosine squared x. And let's think about how each of these terms simplifies. Sine squared x over cosine squared x, well, sine over cosine is tangent, so sine squared over cosine squared is tangent squared. This is 1, and 1 over cosine squared is equal to secant squared. Notice that we've started with something that we've known to be true, and we can show if that's true, then this is true. That's essentially what a proof is. Let's see, part B, 1 minus cotangent of x over cosine of x equals secant of x minus cosecant of x. To prove this, I can start with one of the sides and just show that it equals the other side by using some facts that we know. So this I know is equal to 1 minus cotangent, that's cosine over sine. If tangent is sine over cosine, the cotangent, which is the reciprocal, is just cosine over sine over cosine. Now I'm going to get okay, so now let's just divide each of these by cosine. You can think about where you want to end up. You want a secant, which is 1 over cosine. So let's just divide 1 by cosine, and then we have cosine of x over sine x. That is also divided by cosine of x. Now this first one is secant. Here we flip and multiply, so this just becomes 1 over sine x because the cosines cancel out, and then we have secant of x minus cosecant of x. And then notice that we've shown that this is equal to this. That's what we wanted to prove. Okay, part C. Secant of x minus... One thing you don't get from the video is sometimes I try to solve these and then I take a wrong turn and then I have to start over again because whatever I was trying didn't work. Because these aren't easy, they're sort of like puzzles. Secant x minus tan x squared. I want to wind up here with 1 minus sine x, 1 plus sine x. I know that secant is 1 over cosine x, and tangent is sine x over cosine x. So when I write it like that, I have 1 minus sine x over cosine of x, and that is squared. Now it's squared, which isn't exactly what I want, but let me square it out and see what happens. On the top we'll have 1 minus 2 sine x plus sine squared x. And on the bottom we'll have cosine squared x. Which isn't really what we want. Let's back up. Because we have what we want on the top, 1 minus sine x, but the bottom isn't really what we want. Well, let's see. We could break it up like this, and then remember that sine squared x plus cosine squared x equals 1. That means that cosine squared x equals 1 minus sine squared. So we could rewrite this as keep the numerator the same, and the denominator we could put 1 minus sine squared x. And it seems closer to what we want, but still not quite what we want. Notice the numerators is just 1 minus sine x times 1 minus sine x. The denominator is actually a difference of squares, 1 minus sine x times 1 plus sine x. Now the 1 minus sine x cancels out, and we have 1 minus sine x over 1 plus sine x. Alright, that was a tough one. Number 4. Use the trigonometric identity cosine of x plus y equals cosine of x cosine y minus sine x sine y to determine the exact value of this thing here. Okay. Notice that what's in place of x is pi over 2 or pi over 12. What's in place of y is 2 pi over 3. And what's x plus y? It's pi over 12 plus 2 pi over 3. Let's get common denominators. Pi over 12 plus 8 pi over 12 gives us 9 pi over 12, and simplifying that is 3 pi over 4. So all of this is really just equal to cosine of pi over 12 plus 2 pi over 3, which is cosine of 3 pi over 4. Then from your unit circle, that's negative square root of 2 over 2. Well, let the awesomeness of this 14-minute, 33-second lecture sink in. The main thing you need to know is sine squared plus cosine squared equals 1. And the Pythagorean theorem, that's pretty important too. And this is just a special form of it. Think about the unit circle. x squared plus y squared equals 1 squared. Cosine squared plus sine squared equals 1 squared.